Yeah, let's get started.
Awesome.
Welcome.
Yeah, welcome to Symposium. So I think we talked about we're going to do a session with Alex Iafi about Quill. I think we're going to push that to next week. Just he had some other stuff going on, so that way we'll be able to be 100% focused on that and kind of get that all promoted and everything. But today we're going to continue our conversation on streams. And
real quick, just interject with let me see.
Please.
We've been putting together this website at
Oh,
to pitch this. So really all it is now is just a list of all the past symposiums, and it'll should load. I don't know why it's not doing that now. There it goes.
Oh, yeah.
Yeah, the old the YouTube videos for our old symposiums. And like a link to the top of the upcoming ones. It's going to obviously change. You could filter by sort of topic. So if you want to learn about macros, we did a couple on macros or ZIO test, only one on ZIO test, etc. Architecture, fancy type stuff. So yeah, check that out if you want to look at the back catalog in a way that's slightly nicer maybe than YouTube's playlist feature. But obviously, we're going to try to add more stuff eventually, but we'll also update that. So scala.school should take you there if you're curious and want to explore the back catalog. Some things are missing that I have to add still, but.
Yeah, really amazing start from Kit, and we're going to be adding to that over time. And maybe at some point we'll get a little bit of meta and we'll have like a symposium on building the website to like view the symposiums. That would be interesting. Yeah, we might get caught in some kind of infinite recursion there.
I think that's inevitable.
Yeah, and I guess one other thing, we are hosting this one with our Berlin ZIO meetup group. We're obviously kind of virtual, but we virtually kind of go around to the different meetup groups. So definitely want to give a shout out to all of our friends in Berlin who are coding with ZIO. Hope you had a good week, and we can get your weekend off to a good start here. All right. So today we're going to talk about streams. So last time we built up to actually having our own implementation of streams. And we built up to the ZIO 1.0 implementation of streams, which you can think about as this idea of an effectual iterator. So we said a stream had some managed scope that you opened when you started processing the stream. So that might be like if the stream was getting values from a file, this managed scope would describe opening and closing the file. And then you got this ZIO effect that was essentially a pull that you could run multiple times, and every time it would either give you a new element of saying like, hey, here's an A. You can call me again, I might have more A's for you. Or it would give you this failure that had this option of E thing. And the E would be, there's an actual error, an error occurred, don't try asking me for values again because I just failed. Or the none case here would be the empty case of the stream saying, I'm done, I have no more values for you, you should go on and live the rest of your life, but you should not call me again because I'm done giving you values.
And real quick, we received a hot tip in the Zoom chat about enabling Zen Mode for more real estate potentially. I think if you maybe open up the command panel and type in Zen, because that's something like that is in IntelliJ. I think you need the
little Zen.
Hey,
ooh, hello. Hello. Huh. Definitely more focus.
Yeah, but we do need the terminal. Yeah, I'm not sure.
We want the terminal, and I'm not sure this. I mean, it's less distracting, maybe, but I'm not sure that like having that space there is helping us. So I think maybe I will revert that.
Now I guess to the right side as a split might be possible as well. But yeah, we can explore this. But that's a great.
Maybe we will do that offline here.
Yeah, exactly. But we'll
thank you for the suggestions. Yeah, I'm sure that there is ways we're not fully optimized for this right now. So we have this idea of the stream as an effectual iterator. And we looked at how this was actually the purely functional version of a normal iterator, where in the normal iterator, we call this has next to see if we have a value or not, and then we call next every time we want a value. And this just really wraps all of that up in this one value that here we can call it repeatedly to get the same effect as if we called next on a normal iterator that we used to. And we use that to implement both some basic operators and some basic constructors. So we created a stream that just emits values from an iterator. And then a little bit more exciting, we created this stream that emits lines from a file. And Kit was nice enough to, I think we created a cool file that had some cool stuff in there.
Yeah, it was awesome.
And then we also implemented some basic stream operators. We implemented a way to tap the stream. We implemented a way to map the stream, to take values from the stream. And we implemented the first of our ways to actually run the stream, because we wanted to actually be able to show an example where something was happening here. So we implemented this RunCollect method that would only really make sense for finite streams or streams where we've taken a finite number of values, but it's just going to run the stream and collect the whole thing into a result. And so, yep, I think we added a delay here just so we could see that. And we are reading all these lines from a file very slowly because we manually added a delay. I think maybe we had 15 lines, so hopefully we'll be done shortly. And there we go. So this time we want to explore syncs, as well as a little bit more about streams as a way of architecting our application. So last time we spent a good amount of time talking about this idea about streams producing values incrementally, and that being one core way to think about the difference between a ZIO REA and a ZStream REA. That the ZIO is all or nothing. It's either I'm processing and I don't have anything for you, or I'm done and I have either an E or an A for you. Whereas a stream is you can ask it for values multiple times and it'll have values now, but it may also have values in the future. If you say, I want all the tweets about Taylor Swift, right now there are a bunch of tweets you can get, but a minute from now, probably by the time you get the first bunch, there are going to be more tweets because there are always people tweeting about all sorts of crazy things on the internet. And so we can pull from the stream again and again to get more values from there. So that we can think of as like the fundamental difference between a ZIO and a ZStream as a data type. But another way we can think about it is we can think about streams as a way of structuring our applications. So ZIO is very flexible. Every ZIO effect can embed arbitrary side effect in code. And so ZIO gives us this complete language where we can do anything we want within this world of ZIO, and we can structure our program any way that we want to. We could get some input and do something with it and then send it somewhere, or we could have some queue that has a bunch of workers pulling from it, and we could just put it in the queue and the workers could do whatever they're going to do. We have basically complete flexibility with ZIO to structure our application however we want. And that's why ZIO is the foundation of everything we do, because it's flexible enough that whatever program we're writing, as long as it's doing some kind of interaction with the outside world or concurrency, which is basically everything, unless maybe we're solving math problems, ZIO is going to be able to be the fabric that we use as the basis for that. But sometimes the flip side of that is that because of that flexibility, ZIO itself doesn't give us as much guidance about exactly how we should structure our application for a particular problem. There are some ideas that we can definitely take from about architecture of using layers and separating different levels of concerns, but beyond that, there are often a bunch of different ways we could structure our application to do what we want, and ZIO itself is pretty agnostic between those. Whereas what ZStream can give us is it can be a little bit more opinionated, where ZStream essentially suggests to us that our entire application should be structured as what we could think of as some kind of data flow graph, where we have some kind of input, and then we're going to do some processing on it, and then we're going to have some type of output in the various simplest sense. And we can do fancier things in here of, it may not be one processing thing we're doing, it may be 2 or 3 or 10 or 100 different processing steps, but we have some input, we're going to put them through these different processing steps, and we're eventually going to get to an output. And there are some more complex ways we could think about constructing nodes in this data flow graph we're building. We could think about having what you might call fan out operations, or we'd also call these like broadcast. I think I'm gonna have a little bit of challenge doing this in the in my little ASCII world here, but we could imagine maybe some cases we want to send this to processing 1, and this is going to go to out, if I can type. But then we're also going to take that same input and we're going to send it to processing 2. And maybe then these two are going to fan back in and come back in together to that same out. That would be a little more complex way of building our data flow graph of here. Now we've got kind of one node that's going 2 different places. And then at this point here, we've got 2 different places that are coming together into one place. So this is definitely a more opinionated way of structuring our application. Of it's saying, well, it's always basically this like just graph of kind of data going from one node to potentially more than one node, or more than one node going back into one node. And that's not necessarily the way we want to structure every application, but streaming is a pretty popular approach, because it turns out that it actually is a way of structuring a lot of different applications. And by having a little bit more of a opinion on how we're structuring things, it lets us implement some of these higher level operators that just do more for us. This whole concept of, we'll take this input and send it to these 2 places, that can essentially be one operator on streams. That's what we call broadcast on streams. And this way of like, okay, I've got these 2 inputs and I want to send them to one output. There are a couple of different ways we could do that. We could say, well, just grab each of them as they're available. That would be like the merge operator on streams. We could say, grab them pairwise. That would be like the zip operator on streams. There are a couple of a little more complex ways we could do it. If there's like a zip with latest that kind of does them pairwise as soon as one or the other emits a value. But if we kind of say that this idea of just we have this like graph and things are just going through the graph is a world that we can live in, then that specialization gives us the ability to define a lot of these things that just make it easy for us to write pretty high level logic. And that's what we saw in some of the very early like symposium videos we did, where we had like the ZIO slides app, and we had these events, and there was this logic of like, we'll broadcast the events out to everyone and update things based on them. And we were able to describe that in a pretty high level way. So the other thing that this starts to lead us to is this idea that if you just look at this, you kind of naturally, you see there are like 3 steps here. There's like the in, there's the processing, and there's the out. And so the in is definitely a stream here. And one way you can think about that is if you think about either a ZIO REA or a ZStream REA, both of these are kind of making A values from nothing, right? There's no input, there's the environment type, but putting aside the environment, because there might not be any environment, both of these aren't taking anything in, and they're just creating A values. So you can almost think about like the effectual version of this would be a ZIO is like a thunk. And you can think of a ZStream as the same thing, but having many values. So a ZIO or a ZStream almost says, well, out of nothing, I'm going to produce a bunch of A values. And the reality is not really out of nothing. It's out of something that's hidden inside the stream or hidden inside the ZIO of when we had like the from iterator constructor. It's not really, they're not literally coming out of nothing. They're coming out of this iterator. And when we had the lines, they're not really coming out of nothing. They're coming out of this file. But at the level of working with the stream, we don't know anything about the file or the iterator. We just know somehow this is going to produce a bunch of A values for us. So this stream we can think of as like the input to our data flow processing here. And so one way we can work with the data flow processing is we can just chain more and more operations onto the stream. So that's kind of what we saw. Let's find a good example, like here. So here we had this ZStream lines we can think of as this is like the source. This is the beginning of our data flow processing. And then here we just created really the middle, or in this case, you could think about it as the, well, I guess where did we run it? We ran it here. So let me actually, I'm just going to inline this just to make it a little bit more clear. So let me comment this out. And I'll call RunCollect here. So here we could think of this as the in, this is the middle, and this is kind of the out, right? I start with this thing, it's gonna produce a bunch of lines, then I transform them here, in this case in a not that exciting way, and then I actually send them to their final destination, which in this case is just a chunk. And so one way we could structure our whole program is we could just like start with our in and we could just chain things one after another after another. And that's like what we've done so far. But where that gets to be a little bit less than ideal is we don't get to describe this middle or this end part here as a value itself. It's just an operator on these streams. And whenever we have something that's just an operator instead of a value, that's a sign that it's not first class in the world that we're building. And usually that also means there are limitations on our ability to compose it. So to see this, I think one thing that could be good to do is let's implement one other way of ending one of these streams, and then let's see what happens if we want to use more than one of these ends. So to do that, we can think about having the corresponding version of this lines operator here. So this line says, well, given a file, read everything from the file and let me do something with it. So one operator that could be interesting then is a way that given a stream that, let's say that it's just going to be a stream of strings, let's write those streams to a file. So we could imagine something, let's call it maybe run to file. And let's say we have some implicit evidence here that the A is a string. So what we've really got is a ZStream RE string. And let's say that just like RunCollect gave us a chunk, this one's just going to give us unit because all we're doing is writing it to a file. And so how would we implement this? Well, so we have this process thing. And so it's going to give us this ZIO effect that we can pull from. And so we might essentially do a, Well, we'll see if this is actually correct. But so let's create, so we probably here, we need a name of the file that we want to write to. And I think last time we did this, yeah, let's just call that a string. And so here we're going to create a file writer. I'm trying to remember my names of my low-level operators here. I think we can, yeah, that, but
accept a file instead.
Yeah, we could definitely do that, or we can just, I mean, we could just make it based on the name here. So I think we could do ZIO.succeed new file name. That seems probably a little bit closer. So let's see, we've got the file, and so then let's make this, arguably this whole thing should return throwable, but we'll put that aside. And this needs to be E. Okay. And then, right, we need some imports. All right, and now this should be E. Yep, and what do we do here? I think I took away the run because yeah, so let's just make this. I think now we don't need the RunCollect here. Okay. Excellent, back to compilation. Okay. So now we've got these two different ways of running something running the stream to produce some type of result. We've got this RunCollect here that's going to run it to produce a chunk, and we've got this run to file. And we can imagine we could come up with lots of other ways that we want to run the stream. We could have one that just, maybe we call it like run debug, that's just going to print everything out as we take it from the stream. So the problem we run into here is, let's say I've got this here, and what I kind of want to do is I basically want to like run it. Let's say I want to run it and I want to collect the chunk, and I also want to run it to, and I want to write it to a file. So I can't really do that in this world right now, because if I do something like run to file and then RunCollect, well, run to file is just going to return a ZIO of unit. So I can't even call RunCollect on ZIO because RunCollect's defined on a stream. And if I try to do it the other way around, I'm going to have the same problem that like the run to file isn't defined on ZIO, it's defined on a stream. And so each of these kind of consumes the stream, and like conceptually, it seems like I should be able to like put these different ways of ending the stream together. If I should be able to say, well, take all the stuff from the stream and start collecting it in a chunk and write it to a file and give me like the results of both of those things. That like seems like a logical thing I could do, but it doesn't quite work in this world we have so far, because these like endings of streams aren't values themselves, they're just operators on streams.
Can I play the straw man very quickly and ask?
Yeah,
like,
yeah.
Simply, these are descriptions, right? Why can't I just do this? That's nice. Yay! No problem with that at all, huh?
Yeah. Well, so you're basically running the whole thing twice. So imagine that what this stream is doing is it's getting like the tweets from Twitter. So if you have two different streams that are doing these things, you're saying, well, get two different sets of hopefully the same, but maybe a little bit different based on timing, sets of tweets from Twitter, and then write one of them to a file and collect one of them in a chunk. But what you really want is you only want to go to Twitter once, and then you want to take that stream and you want to do something with it.
Yeah, I think one of the things that might be just as, there's an adjustment when you get used to functional effects, with these pure functional streams, this file stream is not a living active stream. It's a description of how to acquire the stream and what to do with it, right? So it's not sort of an already ran file. This isn't going to share the same stream process. We're actually going to open that file twice, process all the lines twice, which is exactly the same. Yeah, and then if you were doing it from a third-party API, they wouldn't be the same. In this case, it would be the same data because it's the same file. I mean, you'd think, but yeah, that's not what you want to do here. We're not sharing. We're at least duplicating work in the best case. In the worst case, where it's just totally incorrect and inconsistent.
Yeah. So to improve on that, we can think about how we capture this idea of stream ends as values. And I think as we think about modeling our domain, there's something that's attractive about that of if you just look at this concept of you've got ends, you've got middles, you've got ends, it's a little bit strange, you might say, that, well, there's like only a value for this one. Like if there are three things here, why isn't there a value for each of them? Or at least, I mean, maybe you can kind of say, well, like the processing is just an operation, but like, why is the in different than the out? It seems like they're symmetric, so there should be values corresponding to each of them. And in fact, we can come up with that, and that's the idea of a sync. Sorry, do you need a re-invite for the collaboration session? Or?
I think I have the same link. I just accidentally.
Okay.
One of the problems with Dvorak is that the Q key is exactly adjacent to the command key. So just, yeah, fun times.
You were outraged by the discussion of syncs.
Yeah, I'm out of here. Yeah. The hot takes are, yes, I have to hold myself back.
So, and this also goes back to this idea of like the stream or the ZIO being like a value from nothing. So a ZIO is like you start with the unit value or you start with nothing and you produce this new value. It's a producer of one value, or in the case of a stream, it's a producer of many values. And so in addition to thinking about, well, you have beginnings and ends, and those should have some symmetry, you could think of what's the symmetry here? Like if a ZIO or a stream is a producer of values, what would a consumer of values look like? What would it mean if we said something that can take one A value and do something with it? And maybe it actually produces some kind of summary value, right? We saw like the one that collect everything to a chunk, it actually produced a chunk. So it doesn't necessarily have to be unit, but what is something that consumes A values and does something with them and either consumes one A value or potentially consumes many A values. And it turns out in the ZIO world, this thing that consumes one value ends up not being very interesting, because what that ends up having the signature of is that ends up looking something like this, right? So it consumes one A value, and then it just produces some summary value, and maybe it can use the environment and maybe it can fail. And so this is just a continuation. We can just get this whenever we want by just doing ZIO flat map F. So it ends up like you could define this as its own data type if you wanted to. And I mean, in fact, I think at least internally it is sometimes called cont or continuation in ZIO in the runtime, but it's not really that useful as a user-facing data type. Just define a function and you could just flat map with it. But this many values ends up being important enough that this becomes what we call a sync or a Z-sync. And so let's start to build up our intuition of what this thing could be. And to do that, it can be helpful maybe to go down and look at how we were implementing.
On the file right there?
Well, either that or also maybe I'll just copy it, but also just the encoding of ZStream.
I see. Just we had one quick question.
Yeah, please.
From Anton, which was, in our run to file implementation, a little below, he asked about shouldn't we be using ZIO dot effect total?
Probably, yes. I mean,
Here.
that's going to require us to have some further evidence that this is a subtype of throwable.
Yeah, and then also on top of this, we probably, as we did in from last time, our lines method, make this file a Z managed instead, or at least bracket this and close the file at the end. So it's we kind of relied on autopilot or copilot to get us this. So this is not the most idiomatic implementation of this. Maybe we could make it better with our sync.
Yep, exactly. So thinking about the sync now, let's go back to our little. So, and maybe let me also just go down, give myself like let's see, where do we get done with the stream? Okay, we got object ZStream. Okay, so here, let's think about having final case class ZSync. So when we think about syncs, one observation that I think we can have pretty quickly from the example of writing to the file is that just like streams can involve managed resources, syncs can involve managed resources, where like that one that was going to write to a file, it needed to open the file and close the file, and it needed to do that all in a safe way, in a pneumatic way, and probably a little better way than we were doing above. So it definitely seems like, just like the stream has this concept of a Z managed, that the sync is going to have a concept of a Z managed. So maybe if I want to, maybe I'll call this just run here, just as a starting point. And so the first thing I might say is this is going to be a Z managed that usually with everything we do, we want to be able to use some environment, and we might want to be able to fail with some error. So initially, I'm definitely going to put the R and E in there. And I'm just going to, maybe I'll put I'll just make a type alias for myself, just so that I can make it a little bit clearer where we've got something and where we don't. So, okay. We've got this sync that needs to be able to manage resources and maybe use environment, maybe fail with an error. What is the sync going to return? Well, so just like the stream, it didn't just return a value, but it returned a particular kind of value. It returned another ZIO effect that, in this case, we could ask it every time, give me another value, because the point of the stream is it's a producer of values. So we don't give it something, we just ask it for something, and it either gives us something or it fails. The sync, we know, is a consumer of values. So I'm going to start that off by, I'm going to give us a in type parameter, and I'm going to make it contravariant because it's the input. And so we could make this a little more specific, and we could say it's going to give me something where I get to feed it an I, and it's going to give me back some result that I still have to figure out based on that. Mm-hmm. And in fact, because we're living in this chunked world, I'm going to say it's going to give me this function that I can feed a chunk of input.
Ooh, chunk world. World. All right.
Did we do chunk world for our streams? Maybe I guess maybe we didn't do chunk
world.
No,
we did. We chunked.
Yeah.
We did.
Let's see. Did we? We did. Okay. So I'm going to stick with chunk world. And so what is going to happen when I feed it a chunk? Well, I think the first thing we can probably say is we're going to want it to give me back some ZIO effect, because we're going to want, when I feed it a chunk, we're going to want it to be able to do something that's going to interact with the world. Of maybe every time I feed it to a chunk, it actually writes that set of lines to a file or prints those lines out. And we've already got an R and E parameter here. So probably a good starting point is to, oops, sorry, I think I might have undid you.
Uh,
So a good starting point here is to put the R and the E in. And then what we still have to think about here is what's this value that I get back from the sink? And so the easiest one might be something, so our starting point might be, we say, okay, well, the sink can produce some summary value when it's done.
Yeah, and this Z is a convention, I think, standing for 0. It's not really anything to do with ZIO.
Yeah, it's nothing to do with
Old
ZIO.
block.
And yeah, I mean, if we wanted to, maybe we should call it O for like out. Or in some data structures, we've started more of a convention of like, we call this like end and error and like in and out, and we're kind of a little bit longer, but clearer, but yeah. So this is continue to go in the right direction, but there's still something that we're missing here, which is this idea that the sink is, it's not necessarily going to give us a summary value every time we feed it an input. Because like if we go back to that one that was collecting everything into a chunk, we like keep sending it elements and elements and elements, and it doesn't give us back a chunk until the very end. It's just kind of sucking up more and more, and it tells us when it's done processing and it's got like a result for us. So there are a couple of different ways we can encode this, but a really simple one would be to say that this is going to give us an option of O. And so the semantics here would be, if this returns an O, then it's saying, I'm done processing. Like I've got enough values, I'm full, and I've got a summary value for you. And if it gives you a none, then it's saying, I want more, right? I'm like the cookie monster, like give me more chunks, more chunks. I'm not ready yet. I need more chunks. And then if we wanted to, I mean, we can work with this, and this is perfectly fine. But if we wanted to, we could do the same trick that we did when we were working with ZStream of we could push that case of none into the error channel if we wanted. So if we wanted, we could rewrite this like this.
And so how would this, I see. So let's say we wanted to have, I guess we'll implement this, but from a high level, like RunCollect it as a sink. That O would be, it wouldn't be a chunk of O, right? It would be just a single element. How do we get that chunkiness back? How do we distinguish that, right? If the out, should that O be a chunk of int or whatever?
No, so that's where, like in the case of the RunCollect one, the O would be a chunk of O, and there would just be one chunk that we would emit at the end.
I see.
So basically, like, I mean, we can kind of move these types around a little bit, but right now the protocol, if we wanted to call it that, would be that succeed with O means I'm done with a summary value O. Fail with E means I'm done with error E. And well, that's not quite right, but that's fine. We would say fail with none means feed me more input.
I see. Fail with none means feed me more input. I see. Okay. And internally, this is going to be aggregating its summary value, maybe via some var or ref or mutable thing. I see.
It's going to be maintaining some state, and the fact that we have both this outer Z managed as well as this inner ZIO is going to give us the ability to update that state as we go.
Okay, awesome. That makes a lot more sense. So done. So in run. Oh no! Okay, I will not do the undo again. So in the case of RunCollect as a sink, that would really truly be a Z sync where there is a chunk of A out there.
Exactly. And there's one more complexity here that I think we won't do for this implementation, at least now. Maybe we could do it as an exercise in the future, but there can also be this concept of leftovers that becomes relevant. And so the idea of leftovers is, let's say that I get fed this chunk, and halfway through processing this chunk, I decide that I'm done. So what do you do with the other half of those values? You've kind of been fed them, but you've decided I don't want them for whatever reason. Of like, maybe the sink was only supposed to collect 10 values and I fed it 20 values. So what ends up being useful is actually to give the sink another type parameter that represents those leftovers. And then, so you'll see like it's kind of an L type parameter. And then you have the option of, in addition to succeeding with the O value, you can succeed with some leftovers. But I think I want to just like highlight that, because I don't want to like be like I'm pretending it's not there. But I think it's probably a little easier to get started if we put that aside a little bit, and we can look at a couple of these, and then maybe we can come back to that depending on time. Does that sound good?
That sounds great. I think slightly simplified versions are way easier to learn, and you can easily extend them once you understand the already good deal of complexity here. So yeah. I think reading the protocol was very useful. That cleared it up for me.
Yeah. And I think that's a really, both for streaming in general, as well as I think sometimes when you're just implementing your own operators, that can be a really helpful way to think about it. So let's try in this world to implement. So why don't we start with that RunCollect?
Oh, quick question.
Yeah.
From Phil Allen,
Yeah.
which was in Discord, which is, I need more, seems more like normal behavior rather than something for the error channel. Is that where you're settling? Or fail with none means give me more? Yeah. And I think the answer is actually, we kind of talked a little bit about this last time where, do we move it back to the right? So now if we succeed with none.
Yeah, so I think maybe that was just a product of our control Z, but I also don't think it's a bad thing. So maybe we just leave it as is, and we just change our, we could just say succeed with none.
But yeah, I think the, I wouldn't mind for the consistency, fail with O.
Yeah.
Oh no, succeed with O.
Yeah. So yeah, I think maybe for consistency for this, we'll put it in the error channel, but I think that is a very fair point. And particularly here, since the sink is potentially going to say, I want more quite a lot, versus the stream only says it's done once, that would kind of indicate that it could make more sense to put it in the value channel.
The interesting, I mean, I think the important thing is that, especially with this, right? Like, it's about the number of states that you're communicating and being able to communicate them distinctly. So we have these 3 separate states, and there are many forms that you could think of that would be equivalent, right? We could even make our own sealed trait type that was like perfectly labeled as sealed trait, result. And it could be, we don't have to use the error channel at all. And it could really be, this triple sealed trait that's either the error or like a case object that just says, feed me more, or done with result, right? And then we could just have a ZIO of R nothing result of E O. But these are all basically equivalent. If you could just shift the stuff around however you want, but whatever makes more sense to you and your code base and your conventions. I mean, there's some communicative power here. I think we're being a little low level because of the more we introduce these intermediate traits, maybe the more overhead we do. I'm not sure if it would be, maybe it's all equivalently performant. But I know that.
Yeah, I think if we wanted to, we could definitely like implement our own data type for this. But yeah, I think maybe I'm just like a little bit trying to just like not introduce too many new data types. But I think why don't we take that feedback? This is good, and why don't we try implementing it that way? So we're gonna, I think I've correctly updated our protocol here.
Yeah, totally.
And I've moved the option to the success channel. Okay, so let's then think about this RunCollect. So the RunCollect's it's not going to use environment. It can't fail. And it's going to take some input. Let's call it A. And it's going to give us a ZSync any nothing A chunk of A. So then if we want to implement this, we can implement it as a ZSync. And so now we've got to implement this managed thing. And so I think an easy way to do this would be a little bit what you suggested of maybe we can just use a ref. And so we'll initially make a ref that has an empty chunk of A, and we'll just turn it into a managed because that's what we need here. And then we'll map over it to get the ref. And then what we want to return here, that was a little bit more complicated. We want to return this function. So I think I can say in here, and maybe I'll let's see if that will compile, or maybe it'll help with the type annotation there. Oh, well, also we don't. Right, so this can't fail at all. And then, oh, right, so this will need to be a chunk of A. Okay, all right. So this is happy now, and it's smart enough to know this is a chunk, which is nice.
Mm-hmm.
So now I've got a ref, and now I'm implementing this function of what I'm supposed to do every time someone pushes a new chunk to me. And so
is this, would this, so we used, I think previously we may have used in RunCollect, the other one, just a chunk builder. Would this potentially be called concurrently in multiple places and hence the ref of a chunk, or is it just for, you know, another example at arbitrary?
I think just for another example, I think we could definitely use a chunk builder internally here.
Gotcha. Yeah. Okay, cool. Lots of people are typing this, so I might interrupt eventually when these come in, but got a lot of good questions today.
Yeah, definitely. So there's like an easy thing that we can do here, right? If we can just say, we'll update this, and we could say, just add that to it. And in this case, normally we just want to add more things onto this. So we're going to have we're not going to have a value that we're ready to emit yet. So I think we can just say as none here. Let's see if this is happy. Okay, so that satisfies the signature so far. Now this is raising one a little bit, you could think of it as either like kind of a protocol question or kind of challenge for our signature here is, what is our termination condition here? Of like, so far this sync is just saying like, hey, you know, keep sending me more, keep sending me more, but it's actually never, as we've got it set up right now, going to terminate with a value. So right now it's not going to be a very useful sync for us.
Ooh.
No, go ahead.
I'm just going to guess and say, well, it probably now, like when you just, a good place to end would be maybe when the stream that we're processing ends, in that case, in which we might want to know not only the value, this chunk, but whether it's done. So maybe accepting an option of a chunk of I. I'm guessing it's going to get more complicated.
Yeah, so I think one way, and maybe the good way to do it here is exactly that. Another way you could think about the same thing is you could just have a contract that like the empty chunk signals the end of stream. That like, hey, if you kind of sent me nothing, then that means that you're done. That means that kind of means you got to make sure you like honor that in the other things you do. But I think that might not be a bad place for us to go here. So then we might say, if in is empty, then we can just do ref.get I can just do as some else. Let's see, is that
Nice.
okay? So we can definitely go. We can try to implement our writing to file as another sync, but maybe before that, we should think about implementing an operator that actually lets us put a sync and a stream together and run them so that we can have at least an initial little example, and then we can make it more fun with files. Does that sound good?
And then composition. Yeah, there is a couple quick questions.
Yeah, please.
To get to. So I think Ivan asks that this, well, or mentions that this is a potentially dangerous sync because we could deal with an infinite stream, and obviously this chunk would eventually blow up. Yes, you don't want to call RunCollect on an infinite stream, either the other version we did or this one, because it would eventually blow up. I guess some ways around this might be to say, give a max size, accept a parameter to RunCollect and only up to a chunk of this many values, and then you're done as well. That could be another overload. But I think, for convenience purposes, I think this does exist as a sync, right?
Yeah, I mean, it exists, and there's a RunCollect operator on streams. So there's definitely, like, you've got to think a little bit about streams of, do you have an infinite stream or do you not? And the other thing there is, like, that can also be handled a little bit compositionally of, even if you have a stream, you could do stream take 100 RunCollect. So like that lets you separate out a little bit the question of like how many you want from what you want to do with them. Because otherwise you kind of have this problem of, like, you can imagine we're going to have like RunCollect, we're going to have RunCollect to map, RunCollect to list. And does every one of these also need to kind of keep track of the number it wants to consume, or do you want to separate out the how many you want to consume from the what do you want to do with them when you consume them? But yeah, that's like 100% valid point that you've got to think about these operators, whether they're safe for potentially infinite streams. Yeah.
And then we had another question, which is, so imagine an Erlang style supervisor hierarchy with a source, a sink, and a supervisor. The source and sink manage demand between them without involving the super. But if something breaks, sink messages the supervisor. I think of the error channel in ZIO as similar to a message to the supervisor. Is that wrong? And if there's a follow-up, which is he was quoting something I said in the chat, which is that it's a little complicated here. That the caller, where is this? The caller, did I write this? Oh yeah, so the caller, which is the ZStream, eventually will be able to respond to the errors or values. So that's to say that we're sort of just using this error success channel. It's just a big value. It's just really a sealed trait, error or success, and we're just using it as a communication mechanism. And it's neither one necessarily has to be an error. Obviously, the error is usually an error. We can interpret it however we want. But following the Erlang metaphor, he responds, the caller is not usually the best place to deal with failures. I'm not sure if you have any thoughts on that. I'm not really too familiar with the Erlang model, but I think the answer to that is just that we will see how it, like, we're about to implement that way of running them, and then definitely follow up if you think something is weird. But did you have any thoughts on that, Adam, or familiarity with the other models of streaming?
Yeah, well, so I think that that's fair, and what we're going to see is that essentially the implementation of this operator that's going to combine the stream and the sink is the supervisor. And if we wanted to, we could even reify that into its own data type. I think we probably won't do that here, but that it is essentially the quote unquote supervisor. And there are potentially different strategies of how we want to combine the stream and the sink. So, like, I mean, if we really wanted to, I think I won't actually go too far down this, but if we wanted to, we could imagine having like a trait supervisor that took a stream and took a sink and ran them together. Let's just play for a second with like what that might look like. Like, maybe we'll call this like StreamSupervisor or something. And maybe this will have like oops, R plus E, I'll call this A, B. And you can imagine you run this with like a stream, that's a ZStream REA, and a sync, that's a ZSync REAB, and you're eventually going to get a ZIO out. Yeah, let's see. Okay. Maybe I need to make these invariant. I'm going to just get rid of the variance here for a second. Right, so you could think of, I think to exactly the point from the question, you could think of there's someone who is going to use some strategy given this stream and given this sync to put them together to produce a value. And in fact, there are different ways that we could combine the streams and the syncs in terms of, do we kind of run them concurrently? Do we like run from one and then send to the other and go back and forth? How do we like handle failures? There's definitely kind of different ways we could do this. At least in ZStreams, we haven't found it useful enough to reify this into its own data type. So another way to represent this is essentially to inline this. And I mean, you could really do it either place, but I think it ends up being a little bit more maybe intuitive to implement it on the stream. But so you can now have something that instead of being like run collect or run to file, it's just going to be run. And it's going to take a sync that we're going to run it to. And it's going to be able to, oh, I don't want to do it there. This is just going to have R1, E1, AB.
Oh, I made it just O for similarity.
Oh, yeah, okay. Yeah, let me just R1, E1, O.
Hey.
And I don't think we're going to be able to be quite that cute, but it's a good thought. So yeah, so let's step back here of like, okay, so this run method is like it's just the operator version of like this like supervisor, and we can maybe have different ways of doing it, but we'll try to do it one way that seems logical. So we've got a stream, it's a source of values. We've got a sync that's going to use those values. So what do we need to do here if we're running it? And so we might say, I mean, we can do it that way, but we might actually even want to do something like we could do process.zip sync.run .use. And then this is a little bit of nonsense right now, so we'll find that out. But let's see if we can at least get that. Okay, so now this is kind of interesting. So this says the first thing we need to do is we need to open the managed scopes of both the stream and the sync, right? So if the stream is supposed to read from a file and the sync is supposed to write to a file, the first thing we got to do is we got to like open both of these like things that we're supposed to be processing between. So we've got like the scope where within this block now, we've got the file we're reading from, we've got the file we're writing to, and now we're able to proceed. And we've also got these two things that fit together in kind of this nice way of we've got anytime we want to, we can pull and we can get a new A value, or did we chunk him or maybe we didn't chunk him? I guess
I don't think we did actually, looking now at
okay. All right, well, we'll
we can chunk it up real quick.
Well, maybe we'll just, at least for this, just chunk them here, but that's fine. So we got a little bit of, we can go back and we can make that chunky. But so we've got this thing that we can run whenever we want to pull more values. And we've got this push thing that we can push a value to, and it's going to either say it's done or it's going to give us an output. And so we can think about in here, we can basically create a little state machine that's going to embody whatever logic we want of how we're going to go back and forth between pushing and pulling. And so there are different ways we could do this. The actual way, if you look at like the stream operator, it's often done is like you'll do this by essentially creating two different concurrent processes, and you'll create like some kind of queue internally. So you might even just create like a single element queue, and you say, okay, well, upstream just run and send values to this queue, and downstream take values from the queue and process them. But I think for right now, we'll do something even simpler. We'll think about it more as just a sequential handoff. So we'll just say, we're going to grab a value from the upstream, we'll process it. When we're done, we'll grab another value, and we'll just create a little like assembly line here. So to do that, I think I'm going to create another one of our little loop things. And so this is eventually going to give me an R1, E1, O, because this is eventually going to be what I want. And then I'll call that. So now I just need to implement this thing. And I think I might actually need some state here. So maybe I'll make this a, maybe I'll just make this a Boolean that's going to indicate whether I'm right now I need to pull or I need to push. And so then start by looping and saying I need to pull. And I could probably even separate these out into two functions. I could have like a pull and a push and kind of do like mutual recursion between them. But I think maybe I'll just start out this way. And so here, oh, and maybe I should give this a different name. Maybe I'll call this like should pull, just so I don't shadow the pull up here. So then I could say, if I'm supposed to pull, then I need to pull from the upstream. And I'm going to use fold ZIO here to be able to handle the different cases of what's going to happen here. And so let's think about these different outcomes. So if I've got this, maybe I'll give myself a little pattern match here.
Oh, I think we put the failure in the success channel.
Well, this is we're pulling. So for, I mean, maybe we should be more consistent. But when we pull, yep. Okay, so let's think about these different cases here. So if pulling fails with an error, then I've got no value to give to the sink, and I just want to fail with that error. So in this case, I could just do ZIO.fail sum E. Let's check this there. Oh, I'm just, sorry. Right, because this, I was using the stream, I need to use that, but here I just want to fail with the E. So here I'm just going to fail with the E. If I got none, then that means the upstream, the stream has no more values. And so I want to transmit that information to the sink. And so I can do that by just calling push. With we said our protocol was when you had no more values, you push chunk empty.
Mm-hmm.
And then we're going to say right now that it's just the protocol of the sink, that once it gets that, it can't have the none case anymore, that it's responsible for giving us some value. So we could here, we could say flat map, and we could say if there's some O, then succeed with that. And if there's none, then do something like,
yeah. Do we handle this in real ZIO, or is this just sort of a consequence? I mean, it seems like it's sort of difficult to get around here.
Yeah, there's actually something similar in ZIO. Okay, so now we've handled the termination cases. So the other case here is we've got a value here. And so in this case, since we've got an A value, we can push it to the sink. And then we'll see what value the sink gets. And so here, we could say, so the sink, we said, is either going to fail with an error itself, in which case that's fine, we're done, or it's going to give us this option of O. And so we could flat map this, and we could say it either has some O. Oh, and I guess I should be clear, this is an A. Oh, no, wait.
Mm-hmm.
No, that wasn't O, sorry. Okay, so if we pushed it and we got some O, then the sink is saying, hey, I'm done, which is great. And if we don't, in this case, it's not that it violated the contract, but in that case, we're ready to pull from the upstream again. So we can loop here. And I think I actually didn't need I think I'll be able to get rid of that. But now let's just do that. Let's make sure that compiles. Okay, so now I think I can get rid of this. I can get rid of this. I can get rid of this. I can leave. That. That. Okay, I think this will.
Nice.
Okay. So now I think this is going to give us what we need to have at least a very simple implementation of running a sink. And so sometimes, like here, I'm calling it run, especially when you have the leftovers, it's going to be called transduce. But why don't we try actually doing something here? So what's maybe let's create a simple example for ourselves here. So let's call this maybe stream sync example. So here we should be able to do ZStream from iterator. Iterator 1, 2, 3.
I don't think we have that overload.
Oh,
yeah, it's our custom iterator.
Oh, it's our custom iterator. Oh, we have iterator from list. Okay,
yeah, that's fine.
Okay,
I mean,
okay, yeah. So I'm gonna, yeah. So we'll say simple stream is that, and then we'll say simple sync is ZSync RunCollect, and it'll collect some ints. And then we should be able to say, maybe we'll call this simple stream program is going to be simple stream.run simple sync. And so this thing should be giving us a chunk. So then I think we can just debug that. And then let's find our run. Maybe I'll copy that down. And now our run is going to be our simple stream program. Let's make sure that compiles. Okay, now we'll have the moment of truth. There's some complexity in what we did, so we'll see if we manage to blow ourselves up here.
yay!
Look at that. So that's pretty cool, right? We just implemented our own version of syncs, and we also implemented our own operator for running a stream with a sync.
Incredible.
And so now maybe this is a good opportunity to try to implement our run to file as a sync as well. And that'll give us a chance to see like a sync that actually needs like the managed resource aspect of it. And then maybe we can actually do like incrementally reading from one file and writing to another, and maybe that'll be a good good place for us today. How does that sound?
That sounds good.
Awesome. So let's do one ZSync. Maybe I'll call it to file.
Yep, and then with the stream.
Yep. And so yeah, right. We'll need a file stream. And so this is now going to be a ZSync that site doesn't require any environment. Maybe we'll try to do this a little more principled, and we'll say it can fail a throwable because we're working with files. And we'll say it takes strings as input, let's say. I mean, we could do different, we could, you know, bytes or whatever, but let's just do strings to be simple. And this is not going to return any useful value because it's just going to do the side effect. And so our first thing is we're just going to have this managed effect. And let me get some auto compilation going for us here. Okay. All right. So now let's try to maybe take the code we had above.
I got it.
And what's that? Oh, or we already auto complete it? Oh, nice.
Oh, I just stole it from above. Yeah. I think it's
nice.
just buffered writer.
Yeah.
So this is, yeah. You might even
and then we need a file writer. Yeah. Yeah, exactly. Well, and this is like a nice, this is where ZManage gets nice because you could just have this concept of a file writer or file that like can be totally separate from your sync, and you could use it in a lot of cases of if you want to just write to files in general, or in this case, we'll use it to write to the sync. So are we just missing some imports? Because I think maybe we did them.
Yeah, I got to steal it. Coming down.
Yay.
Here we go. Oh, same thing twice. File writer.
Okay. All right. So awesome. And now this, let's see, can I do the, oh yeah. All right. So this needs to be a Z managed. So I could just do writer file map writer. Copy. Excellent. Okay. So now I've just got to describe when I get a chunk of input, what do I do with it? And so I think we can actually make our logic pretty similar to what we had above. So we'll say maybe if in is empty, then we're just done. And otherwise, we're going to, oh no, sorry. Well, so sorry, nope. So if it's empty, then we want to do ZIO seed sum unit. And otherwise, we want to really want to write for each of these. So maybe, yeah, this is not quite what we want. As much as the autocomplete is lovely. So I think we probably want to say something like ZIO for each discard in. There we go, look at that. And as, but we don't want it as sum, we want it as none, because that's our protocol for saying that we're ready for more. And then I think maybe I'm just missing a bracket. There we go. Okay. So I think now that encompasses the logic for writing to a file. And this is much nicer now because we've got all the file logic wrapped up here and it's doing the right thing of the throwable and it's all bracketed. So this I think is now pretty nice. And now if we wanted to, we see a little bit of this, let's see, we may need to, if we need to make actually the file to write to, but now since we've separated that, it's pretty easy for us to, let's just do like file simple sync to is going to be, seems like not the worst name for it. So now what happens if we run this to simple sync to? And now we're also starting to see kind of the advantage, oh, right, in our simple stream. So let me do .map to strings. This was a stream of numbers. Okay. All right, so let's try running this. Well, we got the unit value, which I guess is the expectation. It looks like.
It's there. I changed it
Look
to
at that.
Yeah.
So that's really cool. So, I mean, just in our like 2 sessions, we've implemented something that's going to incrementally read from and write to a file. And if we want to do, we can kind of keep making this fancier of we can write to multiple files and close them as soon as we're done with them, or we can do things like that.
As the 8-minute bonus, would it be possible? Because we have these 2 different syncs. And I think the sort of the motivator at the beginning was, well, you can't do both of these. But now that we have this value, can we zip them together and both collect as well as write to a file? Is it, how's the difficulty of zip on sync is the question.
Yeah, so let's give it a try. There are kind of different, like, I think probably the real version, we do some parallelism. Let's kind of play with how we can do it in maybe the very simple way here. But let's go to our ZSync. Where's our class ZSync? So yeah, so far we've implemented some constructors, but we haven't implemented any operators. And so we can imagine an operator, maybe we call it zip, or maybe we'll call it like zip par. Maybe initially I'll just call it zip here, but we can imagine that we're gonna have another sync.
O2.
Yeah, so this one can require maybe an environment that's a little more constrained. Maybe it can fail in some additional ways. And maybe it can only accept some of the input of the first one. And this is going to return a different O2. And maybe I'll call this like zip with. And so, yeah, maybe I'm going to call this zip with par just because there is another concept of kind of run the first sync and take its output and give it to the second sync. But I think here, depending on whether you even implement the concurrency or not, the idea we'll have is just take the same inputs and send them to both syncs. So this will be a ZSync R1 E1 I1 O2. And then we can imagine we have some final function that takes the O and the O2 and gives us an O3. Okay, and let me get some auto compilation going for us here. Put this in just a bracket. Let's see if we can give ourselves. Okay, so yeah, so let's look at this. So I think Kit's doing exactly the right thing for starting off, that like if we're going to work with these 2 syncs, we need to open both of their scopes. But now this is like, maybe call it like push left and push right. And let's see, zip, what is this thing? Okay, now it's, okay, I think, yeah. Okay, so now we're saying, all right, we're gonna acquire both of these resources in parallel, which makes sense. And so now we're gonna have these 2 different push functions, and we're gonna need to implement our own push function. And this is ultimately gonna need to return the out from both and combine them. And so I think I'm just given kind of time and complexity. I'm not going to do actual concurrency here, so we can imagine we're just gonna go back and forth between these sequentially. And so we'd say, well, the first thing we're going to do is we're going to push the input. Oh, maybe we actually, no, it's not the worst. So let's say we're going to push the input to both of these. And then we've got a couple of different possibilities here. So the easiest possibility, which they're compile's done a very good job here, is they're both done with summary values. And in that case, we can just combine those two summary values. Now let's think, and kind of the other easy case here is like neither of them is done. And so then neither of them is done. And so the two that are a little bit more complicated are these two here, where one of them is done and the other is not. And what that basically means is that we're not done, but we need to only feed values in the future to the one that is not done yet. So we could probably just make a couple of little helpers here. What's that?
Would this be another case for a loop or a stage?
Yeah, exactly. Or I think we can even maybe just define a couple of things. We could say something like loop left and loop right. And so loop left is just going to be, so I think we, so loop left is going, yeah, you know, I think probably having a state machine here is a good idea. And so this needs to return the option of 03. And so here, I think we could maybe have something, we could maintain some additional state here. And so maybe we would say, we'll call this like done, like maybe option of Boolean. And so none means neither of them is done. We actually need a little more state here because we need outside of this to know which one, because we need to not just loop for this input value, but we need to know outside of all this where we are. So why don't we give ourselves
more complicated.
a little more complicated here, yeah. But basically what we could do is we could implement one more ref here that would like be like this option of Boolean. And then when we're in here, we look and we see which one is still open and we just push it to that. So I think maybe we can do this here. Let's see. So let's make an option of Boolean managed. Yep. And then I think runs here too. So I think this should be ref. And then I think we can do. So then we have these three cases. So we have none, have some true, and false. So then we can say, if we've got none here, then that means that neither of the syncs are done. So we're going to take that input and we're going to send it to both of those syncs. And then in either of these cases, we're not done yet because one of the syncs wants more input.
And here, are we relying on the syncs to continuously return their solution when they're
So I think we're also going to have to keep track of that. That was the thing I was just thinking that, yeah, I think we may want to, this could actually probably be a option of either O or O2. So it'll basically have the one that is not done yet. So let's see, either O or O2. So then this will be an O. Oop, that should be O. This will be a sum left of O. This will be a sum right of O2. Yep, perfect. And so if the left one is already done with an O, then we'll just push the input to the right one, and then we'll flat map it. And if it's done, then we'll combine them. And otherwise, we don't need to do the ref of setting of the O because we already set it as the O. So then we'll just continue. And we need to just close our brackets here.
Oh, I think we need to say ref.set. Or, right?
And
No,
then,
sorry, no, we don't, we're done.
oh, and then we need to make this with none. Okay. And then those just need to be ZIO effects. Okay.
And maybe this is the case where some sort of like bespoke type, because yeah, we're sort of doing this type math. No, we need to represent these 3 different states, so an option of an either.
Right. This is right. This is a great case to do something. Yeah, oftentimes for these operators like this is a great time to do something like field trait state, and then you could do case object running, extend state, and then like final case class. Left done, extend state, right done. And yeah, then we could kind of make this all much nicer here. I mean, maybe if we, we're going over time, but that's okay. We could make this like state, and then we could say, well, when we start off, we are in state.running, and then we'll set, and this means state dot left done.
Oh, we did not nest it, so just be left done.
Oh, perfect. And then this can be right done. That one just needs to be O2, O. There.
Yeah, because with all these nested options and nuns, all meaning something slightly different based on the protocol.
Yeah, this is a way. Yeah, this is a much nicer way to do it. Yeah. And then
we just didn't nest it here. So let's see.
Yeah.
State O2.
Yep.
And then this would now be.
And then that's just running, which is much clearer.
Yeah. So and imagine if we do the same for everything else, that would be very.
Yeah. And then I think we just have one.
Left done. Oh, this would be right done. Sorry.
Oh.
Hey, okay, now we should test it.
Yeah.
All right, it's only 5 minutes over, not so bad.
All right, so let's okay, so let's do val not so simple sync equals ZSync dot RunCollect. And yeah, I guess this can do, well, let's just make them all strings. So this is going to collect some strings. And then and maybe I'll just make this a string. So this can then be simple sync dot zip with par. Oops. Simple sync 2. And then here, I think we'll say, well, simple sync 2 just writes the file. So that's just going to not do anything interesting. So I think I can just do the first one. Let's see, is that not happy with me? All right, that. Oh, okay, let's see if I can do.
Yeah, in this case, it could be a zip left, really.
Right, exactly. Yeah, we could easily implement like a zip par left, which is nice when we just want to somebody aside. Okay.
Which one are we doing?
So
We're doing simple.
this
Let me
needs to be not so simple sync.
Cool. I'm just going to map over this also, and so it looks different. We'll map first and multiply it by 3 because the old file had 1 through 7. So now we'll know. We should both see these numbers output, and then if we check the file, it should be the new output that we see.
All right, let's see if we did this correctly.
I think we did. There we go. And now check the file.
Yeah.
It looks like it changed. Heck yeah, it did.
Yeah.
All right.
Way to make things exciting. Well, yeah, so I was going to have a little bit of discussion about the middle part, but we will save that for next time. And I think maybe next time, well, we've got Alex's stuff for Quill, but next time we come back to streams, we will talk about middles, which are the one other part we didn't get to here, and we will build from there into channels and the ZIO2 stream encoding. But
Yeah,
I think that was a full session.
Yeah, this is good to sort of fully see the value of streams as syncs, because I think a motivating example was when you wanted to combine them, and we could do all sorts of crazy
100%.
things now that we can combine them.
Yeah.
Well, thank you, everybody.